This video is an introduction to solving three-variable systems of equations. The problem when we come to a three-variable system of equation is that we're dealing with three equations in this point. And our normal tools such as substitution and elimination, whereas they're useful, when we're dealing with three equations, it gets a little much. So the goal is actually to always be able to get your three equations down to two. Because if we can get them down to two, then we can utilize all of the tools that we have, such as graphing or elimination or substitution, in order to actually solve the system out. So this one is, like I said, an introduction, because sometimes you get really lucky. And this one actually told me that z equals 3. It is telling me that that is my final equation is actually a solution already. And so because z is equal to 3, we're going to start by using some sort of substitution and substituting that value in where I see z. That's going to give me 2x minus y plus 5 times 3 is equal to 22. And y plus 3 times 3 is equal to 6, giving me 2x minus y plus 15 equals 22, and y plus 9 equals 6. At this point, notice that I have a two-variable system. So in this case, substituting in z equals 3 was my process of getting us down to a two-variable system. Now I just have the variables x and y, and I can use all of my different methods in order to do that. I will say, before I do either substitution or whether I do elimination, I like to go ahead and put all of my constants on the right-hand side of my equation. So for each of these, I'm going to subtract either that 15 or the 9 to the other side. So that gives me 2x minus y equals 22 minus 15, and 22 minus 15 is 7. And then on this side, I'm going to subtract that 9, and that gives me y equals negative 3. Now in this case, I happen to be really lucky, because by doing that, I actually solve for another variable. We now know that y is equal to negative 3. So normally, in this case, around here, this is where we might use substitution or elimination to try and solve for one of our other variables. But in this case, we got super lucky where we were able to solve it out. All we have to do now is just plug that back in here, which is a type of substitution. So that's going to give me 2x minus negative 3 is equal to 7. So it becomes 2x plus 3 equals 7. Subtract that 3 to the other side. 2x is equal to 4, therefore our x is equal to 2. So in this case, notice that we were able to take a three-variable system by using some method. In this case, it was a nice easy method of just substituting in what was given. We brought it down to a two-variable system. And then we can solve a two-variable system using different methods. In this case, we got super lucky that when we when we put our constants on the right-hand side, we actually solve for a variable, and all we have to do is plug that in. Now, the last thing here is that we're always going to write our answers, unless told otherwise, as an ordered triplet. And our ordered triplets go x, y, z. So my final answer here would be 2, negative 3, 3, and that would be my final answer.